Hello and welcome to the ninth video that I'll be posting on my Java tutorial series. And in today's video, we are going to talk about searching algorithm, specifically for one-dimensional arrays. And with that said, let's start today's video by opening up our Visual Studio Code. So let's, as usual, click on the new file and create a new file just for this searching algorithm. And I'm going to name this searching.java. And just as always, we need to type in the public class searching, and inside of line 2, I am going to type in public static void main string and then args and curly brackets. And as always, this code right here is used for running the entire code. And before I continue, I'd like to already tell you that in this video, I'm going to be discussing two algorithms or two searching algorithms, each with their respective advantages and disadvantages. And the first algorithm that I'll be teaching you is the sequential search. Meanwhile, the second algorithm that I'll be teaching will be the binary search. And as I said before, they have their respective advantages and disadvantages. And since in this video, of course, we're going to be using these searching algorithms to actually search inside of an array, I will of course need to create an array first. And I'll be creating an integer array with the name array with the length of 10. And I'm going to predefine the values inside of the integer array. So this might take a while, so I'm just going to speed things up. Okay, and I've predefined all the values to actually allow us to have this array picture in our brain right now. Because all the predefining values are similar to this picture right here. And the algorithm for the sequential search can be seen below. So let me just comment this and I'll name this sequential search. So the algorithm will look something like this. We have the for loop for integer I equals 0, I is less than array dot length, and then I plus plus. And inside of that, we have our usual if array I is equals to the value. And I will need to actually create a integer just for storing the value. And then below, we can also identify the index found, which will be the index for which we will identify or find. So let me just put in the value here. If array I is equals to the value, then we need to, store that index with the index found. And then we can print out that index after all of the operation. And pretty much this is the algorithm. And the algorithm starts with the value, and this value right here or variable will be storing the value that we want to search. And the index found here is the variable that will be storing the index of the said value. And the algorithm is pretty much simple, where you just need to use a for loop. And then inside that for loop, you have an if array with the index I is equal to the value, then index found is equal to I. And remember, this for loop right here actually runs the code by checking each and every index, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, and up until 9. So basically, it searches every value inside of the array, and whenever it is equal to the value, index found will store that integer value. And this works for the value that I want to search, specifically if it is only one value or one unique value inside of a array. If there are multiple same values, then we can simply, if for instance we have, wait, before I do that, let me just click on run here and you can see how it functions first before I continue discussing further on. As you can see here, The 103 is indicated with index 3, and that makes sense, of course. And this is because when we reach I is equal to 3, or array I here, which is 3, is equal to the value, then index found is equal to I. And I in this case is 3, which is why whenever 103 is equal to 103, then index found will equal to I, which is 3. So yeah, basically this code works because when array I or array with index something is 103, we get index found, which is equal to the index, and that is 3. So it basically works and it functions. And that's pretty much it for the sequential search. But you might be wondering right now, what happens if we have multiple values of 103? I did mention that it will function for single values. But if they're multiple, then you have to modify the code a little bit. And as you can see here, there is the 9 value. And instead of, having 3 and 9, you only get 9. And you might be wondering, what is wrong with this? Well, to put simply, the reason why this does not function is because index found will be overridden. So firstly, of course, index found will be 3. And then, sadly, after index found is equal to I again, it'll be 9 because there is 2 values of 103. So if I were to system out a print line here, index found, you can see that the value will be 3 and 9, 399. And the reason for why this happens is because the index found, or let me just get in my Jamboard right here. So if I were to annotate it, it'll be something like this. Index found is equal to 103, right? So it checks for the 100, and since 100 is not 103, it does not take the index 0, it does not take the index 1, it does not take the index 2, but when it reaches 3, we can see that it's 103, it takes in that index right here, and then, let me just edit that right now, it just takes in 3, so I'm just gonna type it down here, index found is equal to 3, right, because index found is storing 3, and then at 4, it looks back again, and since 4 is not, index 4 is not 103, it does not take 4, it does not take 5, it does not take 6, it does not take 7, it does not take 8, and 9, which is 103 in this case, of course, it takes in 9 again. And the unique thing is, unique thing is that since we already have index found is equal to 3, and then we have another index found is equal to 9, the last value overwrites the previous value, which means that index found is no longer 3, but rather index found is now 9. And this is why we have, 9. And you might be wondering then, how do we store multiple values? Well, to store multiple values, you just simply need to make another array just for storing the value. But I'll get to that later. Now, here's the unique thing. The break keyword, which is a keyword that is used to stop the for loop, when I do that, or put break here, you can see that the value is 3. Why is it not 9? Because, well, the break keyword, if you remember, is a keyword that is used to actually directly stop the operation once the condition is met. And since, we check 0, 1, and 2, and 3, and 3 is the first 103 value, and then there is the break keyword, it directly stops the searching of 4, 5, 6, 7, 8, 9, and directly just satisfy with the 3 here. So it directly says, okay, index found is equal to 3, and there's the break, since the break is inside of the if statement, and it just stops searching, and it just breaks the for loop. And that is essentially what's happening. And this is much more effective if, of course, the value is only one value like this, because we can directly, we can save a lot of space because we don't actually need to search array 4, 5, 6, 7, 8, 9. But if we have multiple values like this now, 103 and 103 again, then we cannot use the break keyword. And it actually, in the end of the day, it depends on your use of the code and algorithm. But if you want to store multiple values like this, here you want to say, okay, we have multiple same indexes value, and we want to store everything. You need to make another array just for this. And the algorithm is a bit, how do I say this? A bit much more complicated, I guess. And here is the way we actually do it. Length same, and then the length same will be like this. So length same is equals to 1, meaning that length same will get the index of 1, and then length same is equals to plus equals to 1. And then since we already predefined the length, we can actually just take this and then create another array, and that array will store the same value, so same index like this, and then equal to new int length same, and then from there we can paste this again and then do this value again. But the different thing is that we take in the array, same index, and then take in the added index be 0, and then we can simply just put in added index, and then we equals that to the I, and then, or we can just do the same code right here, which is index found is equals to I, and then we can simply just put index found, and then from there we can do added index plus plus, and instead of printing out index found, we need to print out the same index. And since I want to, get a good view, we can use the import.java.util.asterisk, which is for, being able to import everything, and then we can type in arrays.toString same index. And if we click on run right now, we can get 3 and 9 inside of an array. So let me explain what is just happening just now. We have the for int I equals to 0, I is less than array.length, and this code right here is just to identify how many values do we have the same. And this for loop right here in the beginning is to essentially tell us the length or the amount of, or the number of same data. And every time there is the same data, it will add by 1. Meaning that since there is 103, there will be length same will always be equal to 2. And for this case, of course, there's 2. But if there's more, then it'll follow the number of 103. And since length same will always be equal to 2, in this case, we know that the same index will have a length of 2, or there will be 2 data. And then what we do again here is we predefine an added index, or an index that we can store value in. And then we just copy the same algorithm here. But the main difference between this algorithm and this algorithm is that the if statement in the first place for the first for loop will just tell us the length or the number of data that has the same value. And this one right here is different. In this case, we just change the index found to be equals to I, which means that it will store 3, and later it will store 9 because 3 and 9 have the same 103 value. And then we just need to store that inside of the array, which is same index, and we use the added index here. And the added index is a unique value or unique at variable that we use to essentially store or be able to access the values properly. So 3 and 9, and then we use the edit index. So the edit index in the first place is equal to 0. So it'll be same index 0 will be equals to 3. And then, as you can see in this code right here, edit index is added by 1, which means that edit index is now 1. And then, thanks to that, when it goes back here and it takes in 9, the value that we want to take in will be same index 1 is equals to 9. And that causes us to have 3 and 9 inside of the same array. And I know this is pretty challenging and confusing for the first time to understand. And of course, this is already a bit more complicated than what I originally expected, because I expected only to teach you the one value. And of course, this also functions for one value. But for now, of course, you don't really need to focus more on the creating on the array. Just focus more on the first sequential search, which is pretty much just this. This right here is our sequential search. Okay? So yeah. But for those of you who are challenging enough and want to learn more about this, I'll actually revise this later on at the end of the video. Okay, and then we can start now by actually learning how to do binary search. And let me just comment this. And then I'm gonna name this binary search. And binary search is a unique type of searching algorithm where instead of just searching directly from, one by one, the binary search is different. It makes use of the middle value and then takes in the maximum or minimum. So let me just open up my Jamboard here and let me explain it to you. So binary search is unique because it takes or makes use of the middle value. So at first, of course, our minimum is 100 and our maximum is 109. And if, for instance, we want to search 103, then what it does is it looks at the middle value, which is 100 and 109. So what's 0 plus 9, which is divided by 2, which is around 4. So it's 104. That's our middle value. And then it looks whether or not our value is smaller or larger than that value. If it's smaller, then our maximum value, which is 109, is transformed and set into 103, one less than the middle value. And then from there, we take in the middle value again, and we repeat that process until we get the value that we want. And that is essentially how binary search functions. And the way we do it is not too challenging. We just need to type in integer min. We need to set in the minimum value and the maximum value that we want to deal with. So we have the minimum and the maximum. And the maximum should always be array.length minus 1. Because as you can see here, the maximum value is 9, not 10. So we need to take in that. So we need to take in the length minus 1 and we get 9. And then we need to type in the index found, which is equal to -1, as usual. And then we have to, yet again, make a variable for the value, which is, in this case, let me just have the same value as this, 103. And then we need to type in the while loop. And you might be wondering, why are we using a while loop? Well, the reason why is because the value or the number of index doesn't matter in this algorithm. It just really needs to slowly check each and every value. And I'll explain that in a little bit. Integer min, which is equals to the max plus min divided by 2. And this is how we get the mid value, which is always the maximum value plus the minimum value divided by 2. And that's the usual math procedure to find middle value. And then we have if value is equal to mid, then we will say found is equals to mid. Let me just fix that. It's supposed to be found is equals to mid, and then else. So if value is not equals to mid, then we have to know whether or not the value is less or larger than the array mid value or the mid value. And forgot to do this. There you go. If it's much larger than our mid value, then we just need to make sure that the minimum value is added by 1. But if it's less, then we just need to simply make sure that our maximum is much smaller than the medium value or mid value. Max is equal to mid minus 1. And I think from there we can just simply type in system.out.println the found, and I've actually mistyped max to mad. There you go. And now if we click on run right here, we can see that we get to print out 3, and it functions. And let me just explain to you what this is actually happening. So you have the maximum value and the minimum value. The minimum value will always be equal to 0, and the maximum value is equals to the length minus 1. And that's because we cannot take the index 10. Remember that the largest index will always be 9 in the length 10. And essentially, this is just telling that the largest index is 1 less than the length. And the found is equals to -1. And from there, we know that, okay, the found value isn't set yet. And then the value here is, as usual, the value that we want to search. And the algorithm here makes use of the while loop because instead of, searching it one by making use of the index, this algorithm doesn't do that. So let me just get my pen right here, and I'm going to indicate the smallest index with blue and the maximum index with red, okay? And the mid value or mid index here will be annotated with green. So we have our smallest index, which is blue, and then our maximum index, which is 9. And 0 and 9, when added together, will get our mid value. And 0 and 9 divided by 2 is 4.5. And 4.5, since this is an integer right here, will give us 4 because decimals do not get accounted for inside of an integer value. So this is directly rounded off to 4. And then if the value is equal to array mid, which is not because our value here in this case is 103, so it goes to this else statement right here and it checks if the value is less than or larger than the array mid. And in this case, since the value is less than our value in index 4, which is 104, our value gets updated. The max, which is red, will change its index to 1 less than the mid value. So that means that it becomes 3. And then from there, you get to add and repeat again. So from there, we get to calculate the addition again. So 0 plus 3 divided by 2, that is essentially around 3 divided by 2, which is equals to 1. And this is our mid value now. And then the algorithm checks again, is it less than 103 or larger than 103? And in this case, it's smaller. So we take in this right here, and it becomes min is equals to mid plus 1, meaning that the value 0, or the minimum value right there, which is 0, is moved to 2. And then we repeat the process again. And that is 2 plus 3 divided by 2 is 5. 5 divided by 2 is 2, and that means that the midpoint is 2, and meaning if we were to take 2 here and move it here, we can know that the value of the midpoint is not 103, meaning that it goes back to the if statement and checks if it's less or larger, and in this case it's less, meaning that the minimum value is added by 1, and that means that the, let me just try it again, the minimum value is now 3, meaning that the mid value now becomes 3 plus 3 divided by 2, which is 3 as well, meaning that the mid value is as well in 103. And that is how the mid value is now equal to the found. Then found is equals to mid, and since found from this code right here is equals to 3 or any value now, the value is no longer -1, right? And as we have discussed in the if statements, the and here indicates and, so both of the conditions must be true for the while loop to continue. And since found is 3 and not -1, this statement is false, meaning that the while loop stops and we get to print out found. And that is the binary search. And yeah, the disadvantage of this is that, of course, other than needing more logic to write when compared to the normal method, the binary search actually can only function when all of the values are already sorted out, like 100, 101, 102, 103, 104, 105, 106, 107, 108, 109. And that is because inside of the binary search, it takes in the maximum and the minimum value, and then you get the middle value, which is assumed to be in the middle value. And the reason why, of course, unsorted values cannot make use of the binary search is because if this is 101, then it just directly breaks the entire code, because how is 101 the last value? And we assume this to be our maximum value, remember? And that's why we need to sort whenever we are using binary search. And on the topic of sorting, that'll be the next video's topic, where I'll teach you some sorting algorithms. But for the meantime, we are sticking with searching, and binary search main disadvantage is being, or the need to actually sort data, as well as being less flexible than the sequential search, where in the sequential search we can search multiple values. The binary search makes use of only searching one value. So if we have 101 again here, 101 here, then the value or the algorithm will fail to function. So it's much better to just use the normal or sequential search when it comes to having multiple values. But the advantage of binary search is the fact that it really searches effectively, because you can see that it only takes 4 operations to find the value. Meanwhile, in the sequential search, it might take 10 operations to find 103. So it's much more effective to use binary search when we are having unique values and you want to search it fast. That's it. And yeah, I think that sums up today's video. I've already told and explained about sequential search and binary search, and now all you have to do is revise. So for sequential search, the algorithm is pretty much just this. Let me get the value like this. We need to make sure that the index found is equal to -1, and we just want to set in a value. And what we do is we use the for loop method, where we essentially, get every index of the array and matches it with the value. If it's the same, then we set the index value to the said index. And if we are dealing with the multiple values, then the only way we can store those multiple values is by having an array. And the way we do that is by making sure or setting the same length of array in the first place. And the way we can do that is by running the for loop first and making sure that we get to set the length, and then from there we create an array with the length, and then from there we undergo the same for loop method. But the main difference here is that we create a variable called added index, and you can call it whatever you want, but the added index, or in this case of course the variable called added index, will be able to actually predefine the values inside of the second array. In this case, the second array is same index. And the reason why we need to do this is because we can't really use I here, because I will, have value 3 and 9. And the only way we can do this safely is by having a variable that cannot be affected in any way other than, after adding itself. And as you can see here, the index value is 3 and 9. And then the same index, added index equals to index found, will be same index which is originally 0 and non-affected by anything else other than itself here, is predefined the value 3, and then it goes to added index, which changes the value from 0 to 1, and then go back to the for loop, and then index found, which is equals to I, and I in this case becomes 9, which is why we don't use I, because of course if we were to use I, then the index will be messed up. And then the second thing is in same index, we add the value again, which is already 1 in this case, and then we get to type in same index 1 equals to 9, and then added index should run once more equal to 2, but the array length is over, and this value of 2 doesn't actually really matter. That's it. And for the binary search, the advantages, of course, it is searching much more faster, and it is much more flexible in huge numbers of arrays. But the disadvantage is that it has to be sorted first, or the values need to be sorted first, and it cannot actually account for multiple values. And the way we do it is by having a minimum value, a maximum value, and the found value, and then we use a while loop. So if while minimum is always less than or equal to max, and found is equals to -1, the mid value will always be updated by taking the maximum plus minimum divided by 2, and that is the normal math operation. And then we need to check if the value is equals to the array mid, or essentially the value from the array with the index mid. And if it's the same, then we can directly say that the found index is equal to the mid. But if it's not, then we update the maximum and minimum position. And the way we do that is by checking in the mid value and knowing whether or not the set value that we want to search is less than or more. If it's more, then we just need to update this minimum value and move it forward a little bit so that we search this region right here. And if it's less, then we just do the opposite, where the maximum will be this, and it just searches this region right here. And that way it shortens the length of the searching, because we cross out the values that are larger or smaller than the value depending on that situation. So yeah, thank you for watching the video. I hope you get to understand more about Java programming, and in the next video I'll be discussing about sorting algorithms. So anyway, thank you for watching, and I'll see you in the next video.